I don't know, Mr. Smith or something. That guy's way better than I am. Anyway, you probably can. Anyway, that's okay.
You got the reference. I'm glad of it.
Yeah, no, I get the musical references. Did anyone else watch the Oscars last night?
Oh,
No.
I watched the highlights and it's hilarious.
Yeah.
La La Land.
I've never watched it. No, I've never watched it.
Kind of sad. I was happy because I had, in my Oscar pool, I had gone for the light for Best Picture.
Oh, you're so lucky.
Yeah, so I lucked out.
Fences.
So I was bummed out because I lost for it, and then but I wasn't. It was right. So that's good. But I felt really bad.
I lost $5 at work.
Well, it's awkward for the people who messed up, but it's also like, obviously it's awful for the people from La La Land who had to go up and like get an award and then have it taken away. It is. It's really embarrassing. But that's also kind of awful for the people who did win, right? Because now you're going up and like, give me that. That's mine. Like, it's, I don't know. Just not good for anyone. That's not how you want that to go down.
It's not good for me. If I had to wait, I lost $5. It was a full lot of work.
There you
I went for fences. I was just going for fences.
Yeah, I still didn't win my pool, but I got closer. So that's good, right? Yeah, I mean, I got closer to winning than I would have otherwise. Okay, so last week we didn't start into our new unit. We took a little bit of time to kind of just go through the test and see some kind of common areas, that were worthy for improvement. I wanted to mention that I'm sure most of you were here Friday, but my policy on test rewrites, just as a reminder, for sure for the first couple units, and we'll see where we go from after that. If you want to do a rewrite, there'll be a similar test, always the same basic format, but with new questions. You can let me know, and you can write it anytime you want this week. It's open between tomorrow and Friday. I mean, I guess today if you want. Yes? Did you not? I must have that for you. There you go. I know you did. So I kind of left you with some pages I thought it would be worthwhile to work on that related to practice completing the square, practice factoring, and practice with the quadratic equation. Any questions for me of that? Anything you want me to go through? Anyone? Anyone? Okay, what I thought I'd do today is we are going to start Unit 2 today. Today's a pretty straightforward lesson. It should be a quick one. I mean, I always say that before I take all week talking my way through a lesson, but it should be quick. Unit 2 is all about transformations of functions. So it's taking functions and moving them around. Does that make sense? So we're going to start with some kind of function, and we're going to learn how we can move it left, move it right, move it up, move it down, flip it, rotate it, stretch it, all different things we can do with functions, and how we graph that. Does that make sense? All right. So today, the first thing I want to talk about is that, and we saw this last unit, right? So a lot of questions, say on a question when I gave you, I don't know, a parabola in standard form and asked you to find the vertex, you had to, what skill do we have to do? We have standard form and we need to find the vertex. We have to put it into vertex form, and how do we do that? Anyone remember? Yeah, we have to complete the square. Good. Yeah, see, be confident, be bold. I was confident. In you, all the same. So this shows us what we're going to talk about today, which is that we can have the same function and we can put it in different forms, right? We could have a parabola in vertex form, and we can take that exact same parabola and put it in standard form. Those two equations don't look the same, but they make the same function. If we put them on a graph, they would look identical. Does that make sense? Today we want to talk about quickly how you can spot equivalent functions, how you can look at two functions and see if they are the same or not. Does that make sense? So I'm going to go through three methods, two of which we will never do again. So we'll do them very quickly, and then one method that is going to be what we do moving forward. Mr. Dominic, so would you mind giving everybody a calculator as well, just so we're all working on the same calculator? So in the first example, I want to look at two functions, and I've named them f and x. And f is 2x plus 1 squared plus 3x minus 2. You want to see that? And function g is just 2x squared minus x. On the face of it, do these look like the same function? No, they look different. But they may or may not be the same function. And we're going to talk about different ways we could check that. What would be a really quick way we could just check to see if these are the same?
Desmos?
Yep, and if I had Desmos, that's exactly what example 2 is. In fact, I even cut and pasted from Desmos and put it right in the note for you. So you wouldn't even have to trouble yourself. But say we didn't have Desmos. Say you're on a desert island and a ship comes up and it says, well, I'm telling you the story if you'll listen. And a ship comes up and says, yeah, we'll give you a ride off this desert island if you answer my skill testing math question. And then they ask you,
Well, I had a spear. You guys have no weapons.
Can you tell me your ability to leave this island rests on telling me whether or not 2x plus 1 squared plus 3x minus 2 is an equivalent function to 2x squared minus x? You could. I'm going to assume on the desert island that you don't have that.
You make it equal to each other and then see if it equals 0.
You totally could, but we're not going to do that. I mean, you totally could, but I'm going to assume that I'm not that smart on this island, which, let's face it, it's pretty safe. So yeah.
You put both the x values as a certain number and so forth.
Yeah, you can just try a few different numbers out and see what you get. Does that make sense? Is it now? Is that 100% guaranteed to be accurate every time?
Yes.
So you're putting your life on something that might not be safe?
Yeah.
That's what you do every time you get in your car, man. Yeah, so we can try out a few different x values. So here, it makes no difference to me. What do you want to try for x values? Give me 3 different ones.
1.
Very adventurous of you.
24.
Okay, there we go.
5.
98.
Oh, well, I only have 3 spaces. Come on.
5.
Listen, I didn't say 24, did I? I think we can all agree that Alondra had the right idea, right? Like just pick small numbers, but that's okay. We can do this. So let's evaluate the function f when we let x equal 1. What would I write here? 2, 1 plus 1 squared plus 3. Oh, that's not where the bracket goes. 3 times 1 minus 2. Okay, do me a favor. Let's just, I want to get past this thing where we do this in multi-step. Just do that in 1 step in your calculator. Grab the yellow calculator, 1 step, plug it in, get an answer.
Well, I was so I didn't even calculate that.
Okay. Well, some of us don't have such immediately brilliant mental math skills. But in my head, I think I get 3. Is that what anyone else got? I'm often wrong. You got 9. Because I'm seeing 1 plus 1 should be 1, squared should still be 1.
No,
2 times 1. Oh, okay, I'm doing my best. Plus 3, which is going to... Sorry?
I did 9.
Okay, may I see what I get? Okay, so 2, open a bracket, 1 plus 1 squared plus 3 times 1 minus 2. Oh, I got 9 as well. And yet I don't like that answer. Well, I really don't like that answer, do I?
You did. It's right.
Oh, I do. I know what I did.
You did 1.
I did 1 minus 1, which, yeah, okay. Or I just did 1 rather. Yeah, so you're good. 9. This is the moment where I'm going to be like, oh, I was just testing you, but I wasn't. I just screwed it up. That's the thing I do. Okay, and what about over here? What do we get?
Oh, wait, let's see how much it is.
Yep.
Let me do that then.
4. You like it on the second one?
Yeah, you're right on the second.
I'm allowed to be right once in a while. Not too often, but once in a while.
Fair enough.
And what do we get?
3. Well, you have 1. 3.
Yeah, I like 1 better. Does anyone else like 1 better? 2 times 1 squared should be 2 minus 1 should be 1.
Oh,
Oh, I
okay.
added.
Right. I've got that nice. Oh, a mess.
Okay, let's try 24. It's just the same thing on your calculator, 1 step, right?
I got that.
Oh, that's a big number.
Wow.
You sure?
Great, but I don't like it.
I am positive this time.
You don't like it? Let's see. 24 plus 1.
Oh, boy.
Square that. It's pretty big. 25 squared is big.
boy.
Did you get 1320?
Yeah.
Yeah, I like that. That's what I got. That's too big a number?
Yeah. Don't put on the numbers. I'm gonna do on the numbers.
Don't beat the numbers.
We weren't asking for this. I'm gonna go on that. Wow.
Thanks.
And did we get 1128 on the right?
What did I do? I got 1 by 1. What did I do?
Can I see?
Oh, I minus 1.
Oh, yeah. You said minus 124?
Yeah.
Yeah, that makes sense.
Look at the top of your answer.
Why do we just say that already to each other?
We can.
Why do we have to do it so many times?
Practice.
Practice.
Yes, it does.
It does not, but it certainly makes things better.
Because we're just taking for Mr. Early and say. There's no such thing as birthdays, when we have these circles yourself.
That I'm what?
Nothing.
Are you making fun of me?
No.
Okay, that's good. I don't make fun of you.
No. You do.
Not till I get to the staff room anyway.
I feel like all staff.
I'm just kidding. Actually, no, can I tell you, this is like the most positive staff room I've ever been in. Everyone here just says good things all the
Wait,
time.
you had that staff?
Oh, yeah. Oh, yeah, sometimes
You talk tonight about that?
sometimes they're like snake pits, but not here. Here it's lovely.
It's lovely. That's teachers.
You don't trust teachers?
No.
I don't trust teachers. I don't trust teachers either, but
I hope you like.
doesn't mean I have to trust them. Don't just take my word for it, by the way. Make sure you get the same numbers I do.
Yeah.
Wow, you guys are really negative today. But I want you to know I still love you.
This is what happens when
I don't know if now.
So yeah,
Andrew.
so here's an article of like functions because we put in certain inputs, and they output different outputs, the two functions. And if two functions take the same input and give you a different output, then they are not the same. It's true, yeah. No, I think you are, as long as you got the answer right. Now here, I gave you similar functions, and it's not actually quite the same function, and unfortunately, it cut it off. But that's okay. You can see here an example of two functions that look different, but are the same. Well, you can see that they graph the same. You can see that f at x and g at x are equivalent. And the nice thing with method 2, which is obviously the quickest and easiest one, if you want to know if two functions are the same, graph them. Listen, I'll tell you right now. And this is a tip I want to give you. When you get on a test or an assignment, on a test, you can test your answers by going on to the graphing function on these calculators. Plug the functions in and see what it's saying. If I'd asked you a question that involves showing work, you're still going to have to show your work, but at least you'll know what the answer is before you start, right? Yes, they're the same, or no, they're not the same. Especially on an assignment, any assignment I give you, yeah, I may say show your work, so I expect you to show it by hand, but the first thing you should do is go to Desmos, plug it in. See if they're going to be the same or different, right? That's the first thing I would do. Make sure you know beforehand what to expect so that if you've made a mistake, you'll know. And then, when I got a little stronger, I'd do the question first and then check on Desmos, right? You want to challenge yourself to see if you can get the answer without being influenced. But even then, I check the answer when I'm done. I want to make sure I get all those words, right? If I make a mistake, I can go back and fix it. Does that make sense? All right. So these two functions are identical. So we would say these are equivalent. Would you prefer that? We can do that. Therefore, these functions. Oh, really? Yeah, I used to do that. I think that's a weird symbol. All right, now of course, the first one is kind of guesswork. The second one is letting something else do the work for you. Of course, eventually this is bound to lead to the third way we check, which is what? Yeah, we're going to use algebra. We're going to simplify the expressions and see what we can find. So this is 100% reliable. If you reproduce the same simplification, functions must be equivalent. Even with graphing in Desmos, if maybe you looked in a window and they looked identical, maybe if you zoomed out, they might all of a sudden have different end values. They make a change. You never know. This you do know. If you get the exact same simplification for these, then they have to be the same. Now, in this example, 2x plus 1 plus 3x minus 2, and g at x, 2x squared minus x, is one of these maybe simplified already? Is there one of these we can't do anything with? It's already as simplified as possible?
G at x is already simplified?
Yeah. G at x is already simplified. That makes sense? We could put a greatest common factor on it if we wanted, but for the time being, it's nice and simple and leave, which means that we can probably leave the right side of this table alone, and often it'll be like that. One of them will be nice and simplified for you already. What should I do with the one on the left?
You can fill inside the bracket.
Yeah, and then just keep going, right? We're going to distribute, collect like terms. Do you want to try this one all on your own, or do you want me to walk through it with you? You're pointing at me. You'd like me to go through it with you. Okay, that's fine. Okay, what would you do first with this? What would you do first? Yeah.
I square everything in the bracket.
That's right, I would too. Are you guys comfortable remembering, we talked a whole day about perfect squares. Let's just draw it out anyway. Let's do this. You can never go wrong by showing your work. Okay, so we can put the two brackets next to each other like that. There's lots of different ways to approach it. My inclination is to want to deal with that 2 first. What can I do with the 2? Yeah, I could distribute it into the bracket like that. What will my next line be then? What will my next line be? Yeah, Andrew.
2x plus 2.
Yeah.
And then in brackets x plus 1 plus
Very
3x minus 2.
Very good. What should I do next? Yeah.
Distribute the second first bracket in the second.
Perfect. So this times this times that, this times this times that, right? Great. And what do you get when you do that? One at a time. 2x times x would give me what? Yeah?
2x squared
Yeah, 2x squared
plus 2x
plus 2x
plus 2x
plus 2x
plus 2
plus 2.
3x minus 2.
Is everyone comfortable with where that came from? Do you want me to walk through it slower, or is that good? Everyone's feeling comfortable? Don't be shy. Don't speak up. Okay, what should I do next? Yeah.
The plus 2 and negative 2 automatically cancel each other out.
Oh, they do. That's true. So this guy here and that guy there cancel each other? Sure. What else can we do? Yep.
Collect like terms.
All right. And collect like terms. What do I get?
F of x equals 2x squared plus 8x.
Okay. So f at x equals 2x squared plus what?
8x.
8x. Great.
No, it's
So
7.
7.
Oh, I didn't do it. Yeah, I meant both somehow, but I did.
Oops, don't say.
Okay. And now it's as simple as looking at these two. And in this case, what do we see?
Everything else is not equal.
It was the same.
What if the odds are actually going to be
The next example.
3 multiplied?
You know what?
So if there's a fraction,
Can I tell you, the first time I ever taught this, I only taught equivalent examples. And then the first time, like in a textbook question or an assignment, people came across ones that didn't work. They were like, well, what do I do? And there was all kinds of panic and freaking out. So it changed how I teach it. Now the first few examples, I do this. And this is my first time doing it. And I'm discovering that it's met with a lot of grumbling. And that's okay. I want you to know that I only cry a little bit at home when I think about all the grumbling. Just a little, like only enough that my daughter's like, hey, Dad, are you okay? But not enough that she starts crying much back, just a little bit. So I want you to know you only cause my daughter just a little bit of tears, so that's cool, right?
You're supposed to shut the door.
And put happy music on.
Yeah.
That's what my parents did. It's like, oh no, it's the happy music. Mom and Dad are fighting again. Anyway, but enough about my childhood. No, my parents actually, they were lovely. They didn't fight until after I moved out, and now they're old and they like scrap constantly. But when I was a kid, they were more boring then, I guess. They've gotten more interesting. Okay, now, unless I screwed up making the question, this one, I do believe this one does work. Now, I'd like to be clear, I often screw up, so it's distinctly possible I did here as well. I'm sorry. I don't know what to tell you. Now, actually, I may have screwed up. We will know in just a minute. But simplification may require expansion. The last example did, right? But may also require us to do what? Yeah, it may require us to factor. So here, let's start. One of these is much easier than the other. Let's try factoring both of these. I actually feel like I just copied and pasted when I should have written a new function. Let me quickly check my example. In the meantime, the one on the left, I want you to factor the top and the bottom. Factor the top, factor the bottom. Oh yes, you know how. Yeah, I did just copy and paste. Is that the exact same as the previous example? Oh, yeah, it is. You bet it is. Okay, so let's change that. Whew, glad I caught that. That would have been embarrassing when 3 in a row didn't work. This should say x plus 2 over x plus 3.
I like the other one.
Oh, stop whining.
What's the difference if they're the same? You just put it there before these are the same.
Yeah, I do want the note to have one example where they are the same. That's kind of the idea.
But there's so much planes in the great plains of life. What are the odds of them being the same?
That did sound like nonsense, I'm not going to lie.
Like, what if there is a world where every moment-
Okay, math time. Okay. How's our factoring coming? Anyone got the top? No? How do you factor this? Yeah,
2 times the number in front of the x squared times the last one.
sure. So 1 times negative 8.
Negative 8.
Okay, so we're looking for numbers that multiply to negative 8, and then they have to add up to what? Negative 2. So what could we use? 4 and negative 2? Or negative 4 and positive 2? Or 4 and negative 1? Or negative 4 and positive 1? Do any of those add to negative 2? Oh, those should be 8s. That's very true. Do any of those add to negative 2?
Yes.
Which one?
Negative 4 and positive 2.
Negative 4 and positive 2, right? Now, again, I'm always, because again, it has been a year for you. So we'll show it in full, actually. So what do I do with those two numbers now? What do we do with them? Yeah.
You write x squared plus 2x.
Yep.
Minus 4x.
Yep.
Minus 8.
Okay, good. And let's go ahead, oh, for goodness sakes. Let's go ahead and keep working just with the top for a moment. What could I do with those now? What do you do with these now when you're factoring by decomposition? Divide them up. What can the front two be divided by? X? Okay, and what goes in the bracket?
X.
Okay. And what can the next one be divided by? 2, but 4, and should it be positive or negative? Negative. And what will go in the bracket? X? Minus 2, negative 8 divided by negative 4? Yeah, positive 2. Now, what's common to both those? What can I factor out? X plus 2. And what remains? X minus 4. When there's no number in front, when it's just the number 1 in front, it always ends up working that these two numbers just end up in the brackets. Do you remember that? They call it the sum and product rule. You should have done a lot of that in grade 10. Does that ring a bell at all? So we do this by, maybe your teacher only ever did it by decomposition. That is possible. I don't know. But if you look, when the number 1 is in front, after you go through these steps, you will always just end up with the two numbers that worked here being the two numbers that are in the bracket. I think I'm just going to keep peppering you guys with factoring practice. Maybe we'll make that like the first 10 minutes of our day every day. That's actually a good idea. We'll start that tomorrow. That's okay. It's when you go back and take some university math, if you ever do, it's the thing that screws you up every time you start a class.
No, that doesn't.
And factors doesn't work with these kind of.
Well, it would work with these ones, but it doesn't work with some of the ones we've done, right? I like factors. In any case, here, what two numbers? What number are we multiplying to? Negative 1, and it has to add to. Okay. Is that impossible? I think you're right.
1 times 1.
It's times like this that I wish that I had made this a 12, so I'm going to do that.
No, you can't do that.
I just did. I just did.
It's in green. It's all you do in black.
I just, you want me to do it in black?
Nope, don't have it.
Honestly, I am not making any more lessons at night. This is pathetic.
Then how do you know people?
Because I just math in my head. Well, and I may have missed it this time. We'll see. I think I did the math in my head and we're good. I just looked at my handy dandy table of factors, so we should be good. All right, so let's make that 12. What could I use? Oh, this is going to work. Hey, okay. Haha. Oh, I'm such a failure. Okay, so this is a negative 12. What numbers work? 3? And those are the ones that actually work. But of course, what else could I have used? Negative 3 and positive 4. I could have used negative 12 and positive 1. Positive 12 and negative 1, right? Keep going, 6 and 2. But in this case, we don't need to keep going because the pair that works is negative 4 and positive 3. Will you guys hate me if I show you that we can just do this? X minus 4, x plus 3? That when the leading coefficient is 1, that always works? Or would you rather I do it full form?
Wouldn't that be x plus 3, not x plus 4?
You want to see it full? Okay, we'll do it full. But eventually we're not going to. Eventually we're going to get comfortable with that. But for now, we'll show it. So I would write x squared, and then what do I put in the middle? X minus, 4x, negative 4x, and positive 3x. Great. Minus 12, not 1, 12. Aha. Okay. Now if we divide this down the middle, what can I divide the first pair by? Yeah, just x. And what do I get in the bracket? X minus 4. Good. And what can I divide the second by? Positive 3. And what does that leave in the bracket? X minus 4. Good. And now what will that factor out to? X plus 3 and x minus 4. Good. Yes, and we're going to talk about that in a minute. First, I want to make sure everyone's on the same page here. Oh, it only took 5 corrections. Hey. Okay, so if we look at this function, we now have x plus 2 multiplied by x minus 4 divided by x plus 3 times x minus 4. And Alondra pointed out very well, is there something that appears on both the top and bottom? X minus 4, which means that this calculation has us taking x minus 4 and dividing it by itself. And when you divide anything by itself, you're left with, we're left with 1. So in terms of something like this, it disappears.
It's just one.
It cancels. And so what answer are we left with? X plus 2 on top, and on the bottom, x plus 3. Now let's look at our right side, our newly corrected right side. I gotta remember to go back and change the master copy of this note, so next year when I teach this, I can look like I know what I'm doing. Next year, my students will be like, he's so organized and good. All of his notes make so much sense, and they won't have been through all the misery of you watching me go, what am I doing? I'm totally lost. Avery, help me. Avery, do math for me. And Avery's like, no, I won't help you. You can drown of your own accord, Orlando. All right, and this one on the right, g at x, was given to us as x plus 2 over x plus 3. I mean, at first it wasn't, but then we fixed it. What do we notice about these? They are the same, indeed. Yay. So f at x and g at x are equivalent functions. Now, these are the kinds of questions where we can end up actually writing really nice, easy ones. Those are test ones. This would end up being, by the time you get good at these, this will be a nice, easy one. These can also get really nasty. Those would be like deep homework questions, assignment questions. They can get pretty ugly where you have to do a lot of factoring and canceling. Yes, sir.
If you're writing the final answer to this equation, could you, like anything like this, could you just do therefore f at x equals g at x?
Yeah, I would be totally fine with f at x equals g at x. That's what equivalent means. That'd be totally fine. There's just one thing I want to note. Are there any domain and range restrictions to this? We'll talk about range later, but domain. Are there any x values for g at x that are not allowed? Anything that would make this equation impossible? This is a fraction. What makes a fraction impossible? It's a division question. What do you think? I want you all to write down a value of x you think is not allowed for this function. Yeah, write it down. A value for x. So we put x here, we put x there. Is there a value that we could put in for x that will make this whole thing just blow apart? It won't work. The equation doesn't make sense. What do you think? Well, what's one of the impossible I'll tell you one impossible thing in math that at your level of math is impossible. I can't square root a negative number, right? Now that doesn't apply to this one. But if I had an equation where I had to take a square root and there was an x in there, I couldn't let that thing under the square root end up negative. Does that make sense? That's impossible. What else do you know about math that's impossible? I mean, mostly it's just a field of possibilities. But what else is impossible in math? You can't do what? You can't divide by 0. Is there a value of x that would lead to you dividing by 0 here? What do you think? Yeah. So we would say that in the case of g at x, x can't equal -3. Does that make sense? Yeah. What about over here? Are there any x values that make this whole thing impossible? Okay, so definitely the same one. Definitely x cannot equal -3. Any others? Any others? Yeah. Nope, -2 would be fine. That would give you -2 plus 3 is +1 on the bottom, and 0 on top. That would be 0. You can take 0 and divide. Trust me, I spent a lot of time in my life having 0 money. So if my wife and I was splitting our income evenly, and you go, okay, we've got 0. It's the 27th of the month, and we've got $0 left in the bank. Can you divide that between 2 people? Yeah, you betcha. You don't spend any money, I don't spend any money, and everyone gets out safe. All right, so yeah, you can have 0 on top when dividing. That's allowed. Listen, if it was the 27th and that was the number, we were doing great. It was those months when it was like the 16th, and you're going, okay, all right, well, we got some food in the fridge and half a tank of gas. We can do this. It's carpool. So no, I don't mind. What about before we canceled? What about before we canceled?
4.
Yeah, x can't equal 4 in this case. For the function f at x, even though it simplifies down to this, it has an additional restriction. Does that make sense? The function g at x had one restriction. What x value is impossible for g at x?
-3.
Just -3. But the function f at x had 2 restrictions. Does that make sense? You can try it. If you go and put 4 into this original function here, it won't work. Anyone want to take the challenge? See if they can put that in the calculator? Just put a bracket around the top, bracket around the bottom. You should be fine. Yeah, and it'll say go to syntax or something like that. And then you can go, Would it be 0 divided by 0? 4 squared is 16. Yeah, it would. Which is like just as impossible as anything else divided by 0. But yeah, it's not allowed.
It's the Siri Cookie Monster.
So these are equivalent except when x equals 4. It's the only exception. They don't share the same restriction. Does that make sense? Equivalent functions, different restrictions. Good. That's what you wanted.
It says divide
By the way, a lesson from our test too, right? Sometimes error is the outcome we want. right? Sometimes you punch everything into the calculator and it says error, and that doesn't mean you've made an error. It means that the math is impossible, and sometimes that's a good answer, right? And the question on our test where does this line meet this parabola, if you plug that quadratic equation in, it gave you an error. That was good. That was telling you something. It was telling you that that line and that parabola never meet. With no intersection. Either that or you did it wrong. So keep in mind that when you want to know what's impossible, and this is something you're going to do in your homework, you have to look at it before you do restrictions. Can I just throw, not on the note, but just maybe on a scrap piece of paper, throw a few examples at you and have you give me the restrictions, and then we'll go on to our homework? Can we do that? Yeah, just any way you want. Let's just get a little practice. Okay, if n at x is equal to I want you to simplify and state restrictions. Simplify and state restrictions. So I want you to cancel anything that you can cancel, and I want you to tell me what values of x make this function impossible. I'm going to check my little sunlighting. I'm feeling a little dreary. I know. It's really beautiful out. And the weekend, while beautiful, was chilly. At least all the off to that side. That's not even fraction. Then a fraction is the top ever makes a fraction bottom. Right. So you never have to think about that. That's where the restrictions don't have to think about that. So what 2x out is two fractions. It'll be 2 impossible x. What x out is this? What minus one? Yeah. Good. Okay, so that one is the one like this one. 3x minus. Almost. That is. There it is. There it is. I have a viewer. Hello, viewer. You're watching from home. No, maybe. I don't know. That's okay. I had to be evaluated once, and I thought it would be fun to, instead of having the principal come in the room, just like log in and watch from the office. And then I realized there's a fundamental error in that, which is that even like the meanest kid generally doesn't want to make you look stupid in front of the principal. So principals in the room tend to be a little bit nicer, a little bit more, you know.
Hey, look, did you pop up on you?
There you go. A little bit less free with, criticism than they normally would be. And then when, they don't know the principal's watching, they just talk the way they normally talk in the class. And I thought, I don't know if this is a great idea. And it ended up being fine. It's stuff.
No, she left at one point.
And she wasn't enthralled. She wasn't so amazed.
Oh, no, there was an Amanda Whitfield.
Oh, so when you do a fraction, what's the never divide that? Yeah. Does the top ever matter? Can the top of the fraction ever make it impossible?
I'm here, good
So
going.
when there's five restrictions, you never have to list them.
I just know who she is.
And there'll be as many restrictions as there are.
So we had 3.
So how many factors?
I'll have
There's
passion.
two impossible values. You just have no one bracket at a time. What value of that can make this? Yeah, one of the restrictions of x can't be 4. And what about this bracket? It's tricky, right?
Alright.
Actually, to use
That was what
one is just to say.
Oh.
No, it's not something. 3x minus. And now this thing.
Oh, no way, as
They have to
a
move. Good, so we have to move this on. Yeah, no. Yeah, that. And now what do you do? Do that. And what we doing? And remember, these aren't equal as. Right? And dividing off this one. Not what we do. Now 3x.
That's what you went on, saying whether or not you let
That's why I want to go, yeah, that would make me want to go less.
What are the two possible values? Yeah,
Is Trina Boise there?
she is, yeah.
Take up the guys, please.
You bet.
Thank you.
Does that make sense? So x can't be one. X can't be one. Once you've done that, now you can look at this and simplify. You cancel out the threes on top and bottom. Anything good on top and bottom? The whole bracket. No, it's okay. Good, yes, you can cancel out on top and bottom. This. So you said x can't equal to that 1. Good, so that takes care of that bracket. We'll get this bracket. Can I show you how? There's 2 ways, and I'm going to show you the hard way first, and then we'll teach you how to make it easy. All you have to do is you say 3x minus 2 can't equal 0. Right? So now if you want to get x by itself, what would you have to move first? Eventually we're going to have to move it to 3. Yeah,
My mom
so
was
show me that.
expecting this.
And just instead of saying equals, say can't equal. Good. Now to get x by itself. You can do this. You know? Absolutely. But that's good, that's right. Does that make sense? Now the quick rule of thumb, just like finding the roots, is flip the sign, divide that number. That makes sense? That's what's possible. That's just all it's doing is this. It just saves you having to write this out. Does that make sense? Okay. So let's go through this example. I think everybody got it. But let's be sure that we're all on the same page. How many factors are on the bottom? How many brackets are we looking at? Everyone see them? So how many impossible values for x will there be? Yeah, each bracket can break this equation. Does that make sense? Do we ever have to worry about the brackets on the top? Can there be a number on top on the numerator of a fraction that makes it not work? What? Yeah, fair enough. So as long, if we're worrying just about the top, so from x minus 1, what's the impossible x value? 1. We just flip the sign, right? We would just say x can't equal 1. Because if x equals 1, we're dividing by 0. What about this one? Well, let me just show you the long form in case you need it. We would say whatever 3x minus 2 is, that can't be equal to 0. Does that make sense? Well, if I wanted to isolate x here, what do I have to do?
Add 2.
Yeah, we're going to add 2 to both sides to get rid of the 2, and that'll leave me with what?
3x.
Okay, and then what do I have to do? Divide both sides by 3, and that would leave me with x cannot equal 2 divided by 3. Does that make sense? Now, what's the quick rule of thumb of how to get from this to this? Flip the sign of the second number, divide by the first number. Now, that's just doing what we already did algebraically there, but it just saves us having to write it all out step like that. Does that make sense? If you're uncomfortable with shortcuts, some kids are. Some kids, like, if they write this out, they get it right every time, and they are always forgetting this or mixing it up. If that's you, I'll give you a hint, that's me. Then write it out every time, right? If you're like me, if you're the kind of kid who tends to make a mistake, if you have like a little thing to remember, but you can do the algebra and it helps you not make a mistake, then do the algebra. Okay? Now, is there anything, now that we've stated our restrictions, can we simplify this equation? Yeah, how can we simplify it? Yes, ma'am.
The 3 minus 1 and 3 minus 2 cancel each other.
And what am I left with?
X plus 4 over x1.
Yep, x plus 4 over x minus 1. And more often than not, if we're left with just one factor, they will write it without the brackets. The brackets are seen as wasteful in a case like this. Though if you left the brackets there, I would not tell you that you're wrong. I don't care. Can I give you another one? Okay. Okay. Same thing. I want you to state restrictions and simplify.
Oh, there's way too much.
There is not way too much up there. Get to work. Hi, London, Mom. Get to work.
I'm definitely not going together like that.
No, I own it. I think she'll be on my side. Right? See,
If she's even watching it.
I'm sure, yeah, I'm sure she's tapped out a long time ago. So it's funny that you mentioned that because I was thinking the other day as I was writing, you have to like sign your kid's report card, that I distinctly remember the last time I ever showed my parents my report card. That was in grade 5. And I remember in grade 6 not liking the comments on it, so I refused to take it home. And they kept telling me, like, you need to bring your signed report card back. And I just never did, and eventually they gave up. And that was when I learned that teachers are forgetful too, and eventually they stop hounding you for things. I was a slow learner. I still am. All right, state restrictions, simplify. Yeah. And simplify. Oh, you can leave it back before that. Yeah. You don't want to cancel? Yeah. You're not wrong. Like what you're doing isn't wrong. It's because it's okay to leave it just back and forth. There'll be times when you have to extend, but unless you've got a reason, unless you're going to do a next step, you need help or something. Back and forth is usually considered the more simplified. And I think let's see the ways. What are you doing now? How are you doing? See? Yeah, you do it. Yeah. Don't like this calculation. Why don't I like it? Yeah, they're not the same. But other than that, everything's good. So just change that, but everything else is good. Yeah, good. Oh. Yeah, I'm lost. Oh, this is how you worked it out. Okay, you're good. You're good. Oh, I see.
Oh, so what was my name? I mom is so weird. Oh, Mr. Orlando, he says hi there.
Oh, good. Okay. Oh, what is this one? Which one of these factors did that come from? Okay, and what do we do?
I'm not saying it's a bad thing.
Instead of doing zero, right? So, D over here, what is that?
Those things are expensive. Well, I'm gonna get one. Oh, actually, it's like, oh, you go, I'm confused.
Yeah, it's just the sign. Yeah, just the sign. And so the quick rule of thumb is we flip the sign and divide by two.
Wait, I want to say hi.
Other than that, it's all good.
So say hi back. You're not saying it loud enough. You're pressuring me.
We don't peer pressure people. Okay.
No, my mom
Yes,
does
you
that. I don't do that.
I don't. First of all, I'm not your peer. Second of all, I certainly don't pressure my peers to do anything.
Oh, yeah, because
Um,
such a high authority, everybody wants to be liked by you as the teachers.
Are you making fun of me? I think they want to be liked by me. I don't know. I want to be liked by them. I think by and large, when you enter a social setting, you want to get along with people. You want them to like you. You want to be liked. I don't know. Anyway, apparently not Andrew. Indeed. What restriction would we get from this bracket? What restriction would that give us? Or how would I find it? What? Yes.
1 divided by 2.
1 divided by 2. Okay, so x can't equal 1 over 2. Because we take the second number, we flip its sign, and we divide by 2. And if you want to know why that works, it's that same algebra here. Does anyone want me to draw the algebra out to have it make sense? What? Is that what I said?
Yeah.
That's like my East Coast moment.
Algebra.
What about this one? X can't equal what? -2. Good. And what restriction do we get from this one? X can't equal 2. Good. Now, to cancel. Anything we can cancel? Yeah.
It's my step.
Yeah. Anything else? Nope. Why not these two? They look similar.
Because they have different, like, they're positive and one negative.
Good. They have to be exactly the same. That's the most common mistake. And that's why we'll see a lot of questions where we throw things like that at you. And so we end up with what? Mm-hmm. Very good. Well done.
Can you just please put a line through that sign?
Don't know why you don't.
No, he's correct. It should be there.
Why not? You gotta respond. Come on.
Okay. Do you guys want one more example, or do you just want to get to your homework? Homework? All right, get to it. If you do want a bit more help, let me know. I'm happy to come sit and help with you.
No,